All right, we had 3 questions as usual. The first problem was a true and false. They pretty much want to know if it worked. Some of you noticed it was highlighted. You all know me. Give me some work or an explanation. Either you showing us shields or you telling us something that you know. All right, who want to tackle A? What can we do to figure out if that's true or false?
Kept the zeros.
Jamal, I think I told us yesterday, don't confuse it as thinking it's always the zeros. So we actually have to count more zeros.
You see how many every 6.
How many comes?
All right, so if we were to take the value that they gave us, we shift it over to 5 and 4, we should have 60. Let's see. How many numbers are behind that decimal?
5.
5. So that exponent is incorrect because the exponent they gave us was 6. So that 6th one would have had that at 4,250,000. And you could have shifted 6 times. 1, 2, 3, 4, 5, 6. Fill in those missing places with zeros. And then add your commas. So that clearly was false. All right, number B, we could have did the same thing. They placed the decimal behind the 6. So I'm going to place the decimal. And then ask yourselves, how many digits is behind that decimal?
12. Wait, no.
10.
11.
11.
Looks like it's 11. They told us it should have been 9, so that one will be false as well. All right, with these negative exponents, they will work the same way, except this time we will go in the opposite direction. So this one is a -2, so we will shift 2 to the left. 1, 2. Add a decimal and fill in that missing place with a 0. So that number was 0.0511. Is that the same answer that they gave us?
Yes, no.
Look closely.
Yes.
You got a decimal in front of that 5?
Wait, no.
That one would be false. It was not the same. And we kind of could have recognized this 100th place, and then this is a negative. So we kind of should have known that that was going to be a very small number, or a 0 at the whole number. All right, for D, we could have did the same thing. It's a -4. So we could have shifted that exponent 4 places to the left. Add a decimal and fill in those missing places with zeros. Is that the same answer that they gave us?
Yes.
All right, so that one was the only one that was true.
I only got one wrong.
Good, Jamal.
Me too.
All right, number 2 said, how is this number written in scientific notation? Y'all know me. Give me more than just some numbers. Tell me what I know or something. Somebody talk to us.
Yeah, more than zeros behind one. You got 10 to a whole number.
They go all the way behind here. All right, somebody else?
You go shift to the right.
How many times?
Five.
Okay, Kendra said 5. Let's check. 1, 2, 3, 4. All right. So make sure we understand that first, we need a single digit in front of the decimal. A single digit in front of the decimal. So that would be that 9. So then we're left with 9.81. The second one is always a power of 10. And Kennedy said we shifted 5 times. And since we went to the right, is that 5 positive or is negative?
Negative.
Oh.
All right, it's negative. And one way to determine is that in the beginning, it was a 0 for the whole number. So remember, that's a very small number. It started with 0. Any questions about it? Some of us had a positive, so definitely make sure we pay attention to if it's a big number or a small number. And you know small numbers, because small numbers gonna have a whole lot of zeros in the front. So that's an indicator of a negative. All right, the last one is which pairs of numbers?
I'm not done yet.
Okay, let me go back. Fall off, but
I'm done.
okay. All right, number 3 asks which pairs of numbers in scientific notation show that one number is 20 times as great as the other number. A rule of thumb with these types of problems do not depend on looking at them. Write them in standard form. Put them in standard form. That's an easy approach to looking at it. So looking at A, I would have wrote that in standard form. 2, 1, 2, 3, 4, 5, 6. 2,000,010. The second one the same way, this time moving 6 times. 1, 2, 3, 4, 5, 6. 4 million. Oh, I left off the one on the first one. 1, 2, 3, 4, 5, 6. Yeah, it's 7. All right, so that was actually 20 million. So then you should have taken a smaller value. Now notice they said about. So about is pretty much an estimate. So you could have looked at the beginning in the millions place. Then ask myself, 4 times 20 will give me 20.
No.
All right, so that means that one would not be 20 times greater. 4 times what would give us 20?
5.
Good job. So the first one was only 5 times greater. All right, then could have did the same with the second one, same approach. 1, 2, 3, 4, 59,700. 3, 1, 2, 1, 2, 3. 3,000. So then once again, we're estimating. Does 3 times 20 get me close to 59?
Yes.
Yes, it does. And then we could have rounded that 59 to 60. Yes, that would work. So B would be one of those answers. All right, we then could have tried C, the same approach. Write that number out. So the first one was 4,910,000. And the second one was 5,000. So then once again, these are in the thousands. And that is the 5. I like to break it apart. We can round 4,900 to 5,000. If I take 5,000 and divide it by 5, what will we get?
500.
1,000.
5,000 divided by 5. What's 5 divided by 5?
It gonna equal 1,000.
5 is 1, and we got 3 zeros, so tag them along. So that one would not work as well. All right, D will work the same way, except now we got smaller numbers. We got some negatives. 1, 2, 3. Add a decimal and fill in those missing places with placeholders. So we got 0, 0, 8, 2, 1. Same with the other. Add a decimal, those zeros. All right. About very small numbers that you may not have known. The more zeros it has, the smaller it is. The more zeros it has, the smaller it is. But we'll still use that same approach to compare. We got 821 and 413. We can round that to 800 divided by 400. What we get?
2.
2. And then patterns in division tell us we can eliminate those zeros that were the same. How many zeros are left?
2.
Look in front of the decimal.
1.
1. Only one left, so we'll tag along 1 to give us 20. So D will work. All right, E, the same approach. 1, 2, 3, 4, 5, 6, 7, 8. And then add the 9, 4. 1, 2, 3, 4, 5, 6. Add the 6 and then the 2, 2. All right, same approach with this one. We can clearly tell that this is the larger number. We got less zeros. No, we don't. This is the larger number. Whichever one is larger will have the least zeros. All right, and then compare those the same as we just did. This is the larger number, so we can estimate that to about 600. And then we would estimate that to about 200. What's 6 divided by 2? No, we can't estimate that 200 around 300.
It will be 300.
294 estimates to 300, so then that'll give us 2. And then the same approach, go through and have a look at those zeros. And we are left with 1. Destiny, I think you were the one who made me go back and look at that one. You were Kennedy, one of you. So just remember, when they give you scientific notation with comparisons, write those numbers out and make that comparison. Another easier approach would be to simply put it in your calculator. Look at this one. If you would have put 59,700 and divided it by that 3,120 something, it would have gave you about 19 point something. So you can always put it in the calculator to help you double check if you just get confused on it. Any questions about it?
No,
No.
ma'am. No, ma'am.
All right, a quick review snapshot from yesterday. You did not attend class on yesterday. You should be familiar with us. We did take notes. Remember, notes are pretty much your cheat sheet. If you take good notes, it will show when you do your classwork. But anywho, scientific notation, that's what we learned on yesterday. It's an easier way to write very large and very small numbers. And that's because the calculator, you can only put about 10 to 12, 9 to 10 digits in a calculator. So for those larger numbers, the calculator had to make it smaller. Scientific notation is a product of two factors. That first factor is a number that's greater than or equal to 1, but less than 10. And that's why I keep saying it's a single digit, meaning in front of the decimal, we need a number that's between 1 and 9. If it's not between 1 and 9, the number is not written in scientific notation. The second factor is a power of 10, meaning the base is 10, and then that exponent would go with that base. Also explain to us that in the calculator, they can't put times 10, so they'll put it as an E. So we just have to kind of notice the number in the front will tell us that decimal, that E is the times 10, and then the number behind the E would be the exponent. Also gave us some steps yesterday on how we can get this done. We can shift the decimal to get a single digit in the front. We need to rewrite it, but make sure we include all the digits before or after the decimal. And remember that the number shifts will tell us those exponents. And then, of course, if it's a large number, we'll have a positive exponent. And if it's a small number, we'll have a negative exponent. All right. We have a short classwork assignment activity in Google Classroom. I'm going to give you a few minutes to go to it and pull it up. I'm going to give you about 5 minutes to see if you can fill in the blanks. If you have your notes from yesterday, The top part can be found in your notes. About 5 minutes. All right, let's have a look. It says the population of China in 2019 was about 1,434,000,000. How do you write 1,434,000,000 in scientific notation? Now the first one says, I know that a number in scientific notation is written as the blank of two what?
The product of two factors.
Destiny, that is correct. The product of two factors. Great job. All right, so then we can keep going. It says the first factor is a number that is greater than or equal to 1 and less than what?
10.
10.
Good job, that would be 10. We said it had to be a single digit, so that's less than 10. It then said the second factor is a blank. Then it said this means that the base is 10. So what is it called with a base of 10?
Integer power of 10.
Good job, Destiny, that is correct. Your notes, I think the only thing missing was the word integer, but you should have had power of 10. All right, this means that the base is 10 and the exponent is our what? They pretty much gave that to you in the name. What was the only word I said was missing from our notes?
Integer.
Integer.
So that means the exponent is an integer. So remember, integer is whole numbers and their opposites. Those positive and negative numbers. It then said to write 1,434,000,000 in scientific notation. I can move the decimal until there is a single non-zero digit to the left of the decimal point. And they showed you how they shifted all the way over. It then says I have to move the decimal point blank places to the blank.
Nine places to the right.
Are you sure they went to the right?
They went to the
I'm
left.
saying the
They went to the left. So 9 places to the left. It then says the blank of the exponent in the integer power of 10 is equal to the number of places the decimal point moved. So what of that exponent? All right, think about it. If we have 10 to the negative 5th power, what is that going to tell us?
Positive.
I'm thinking 10 to the negative 5th. What is that going to tell us, that negative exponent?
That the number is very small.
It's very small. And which way are we shifting, Kennedy?
To the right.
Right? So that would tell us to shift 5 to the right. If we have a number that's 10 to the positive 5th, what is that going to tell us?
Shift to the
Shift to the left.
Good job, 5 to the left. So make sure we have the exponent, that becomes the absolute value. So that's what they mean in the second sentence. The absolute value of the exponent in the integer power of 10 is equal to the number of places the decimal point moves. Try to aim to be on time tomorrow, please. All right, it then says the sign of the exponent depends on whether the original number is less than or greater than what?
1.
Go back and think. Okay, we'll go with 1. Who it is, Zakaya? So that's those small numbers that they are referencing. If it's less than 1, we know it's very small. That's where she get her 1 from. All right, at the end it says 1,434,000,000 is greater than 1. So the sign of the exponent is what?
Positive.
Good job, Kennedy. No, that was McCaden. I'm sorry. All right, so make sure we understand. We shift left, positive, we go right to get those small numbers, it'll be negative. So then at the bottom, they said 1,434,000,000 is equal to 1.434 times what?
10 to the power of 9.
To the ninth power.
10 to the 9th power, and that's pretty much what we had already stated up top. That is your classwork for today. Hopefully you paid attention to get that complete. You can put that to the side and pull back out your math notebook. Everybody got what you need before I move?
Miss Catches, you want us turning it in right now?
Yes, you can go ahead and hit submit, Kennedy. You sure can. Everybody. All right. So today we're going to continue to practice on what we've been going over in scientific notation. Hopefully you got your notes on yesterday that you can use and help model. With this problem, I'm going to give you about 30 seconds to a minute. See if you're able to write this number in scientific notation. All right, it reads, which of the following expressions is equivalent to 4,325,000,000? Jamaya, what you thinking? Veronica, what are you thinking? Shantasia, what are you thinking? If I call you and you don't respond, you might well.
I think it's D.
Talk to me, Veronica.
Ma'am? Because I counted all the zeros and it gave it to 10 9.
So all the zeros gave you the 10 ninths? You sure?
No.
No, you have to count all the numbers behind it, and it will be
Which have been 9 times.
Okay. So I'm gonna go ahead and place that decimal word go behind the 4, and that means I need everything behind here. Stop saying count those zeros. We count every digit behind the decimal. Every digit. Zeros included, but don't forget those other numbers. At the bottom, they said Carson chose A. Aaliyah, why do you think she chose A? Destiny Nicholson, why did she choose A?
Because
Hold on, Jamal. We talking to Destiny. Go ahead, Destiny.
I don't know.
Okay, not paying attention. Jamal, talk to us.
She probably saw the negative sign. She thought she was supposed to go shift the zero and shift the zero left.
All right, anyone else got a response as to why she could have chose A?
She shifted to the right instead of the left.
Or change your word in Zakiah, I think that was you. She shifted left instead of right. All right, and then don't forget those negative exponents go with what kind of number?
Small.
So make sure those negative exponents go with very small numbers. So that should have been an indicator from the beginning. 4 billion is a large number, so I would have already eliminated A and B. So make sure you're checking those exponents. She was correct with the value of 9, but she did not pay attention to that negative sign. Good job, ladies.
Me catching, I thought when you shift to the left, it equal positive.
That's when we go from this, Kennedy, when we go from scientific notation to standard, yes, we'll go to the right. But if we're trying to change it into it, it'll be the inverse to go left. With the negative, we'll go left to add in those zeros in the front. You see what I mean? What she did.
Yes, ma'am.
So it just all depends if they give us standard form to start off with, or if they give us the scientific notation to start off with. Good question. All right, I'm gonna give you about 30 seconds to a minute to have a look at this question. Read it to yourself and see if you're able to set it up or figure out what's going on. All right, it reads, the mass of Earth's moon is about 7 times 10 to the 22nd kilograms. The mass of Jupiter is about 1.89 times 10 to the 27 kilograms. The mass of Jupiter is about how many times the mass of Earth's moon? Jamal, you think you got something?
I think we're gonna have to run it. We had to better see.
All right, anybody else think you may have an idea of how we can approach this?
Well, first we have to write out the numbers because we compare.
Okay, I love it, Kennedy. So we need to write them in standard form. You'll find these to be some large numbers. 27 next one will be larger, so we can kind of put it on top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. And that's why we say we can't place these kind of numbers in the calculator, because the calculator will not show us all of that. So that would be the first one. I'm going to use a division bar because we already know we are dividing or comparing. 10 to the 22nd. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22.
And eliminate all the zeros and divide it. 189 divided by 7.
All right, now I ain't gonna say eliminate all the zeros, Jamal, but we're gonna eliminate the zeros that got a pair. So eliminate all the zeros that have a pair. If it don't have a pair, leave it alone. I should have did better with my lining up.
You 70, I think.
All that zero left too. All right, so yours should look somewhat like mine. So we're now left with 189,000 being divided by 7.
We can round that to 200,000.
You can, but I wouldn't do that just yet, Kenny. Now, easier approach, only look at those whole numbers. So we're actually going to divide 189 divided by 7. Somebody tell us what that might be.
27.
27.
And how many zeros did we have left behind?
3.
Good job. So 27,000. So I love how Kennedy reminded us to write them in standard form. I love how Jamal told us to eliminate those zeros. Just make sure we remember that that's those that have a pair. And then if you need to only separate the way I did and only focus on dividing those numbers, please do that if you find that that's easy. And then count those remaining zeros. Any questions about it?
No, ma'am.
No, ma'am.
All right. Good job, ladies and Jamal. Good job. Did everybody have that before?
Yes, ma'am.
It says, which of the following numbers is not in scientific notation? I'm gonna give you 30 seconds to think to yourself. Which one of these are not in scientific notation? 30 seconds to think for yourself. All right, Faith, you there?
Yes, ma'am.
All right, did you got an answer for this problem?
I think it might be
Eliminate A and B.
Hold on, Jamal, Faith talking to it.
I think it might be C.
Think it might be C. Why you think it might be C, Faith?
Because the number has a 0 in front of it.
And what did we say need to be in front?
A number that's
Number
a number
greater.
a number that's greater than 1 but less than 10.
Good job. And that is correct, Faith. You were actually thinking correct. It had a 0 in the front, so that would not be in scientific notation. Would not be. Now, Jamal, we got to remember, scientific notation can have those negative exponents, so that's okay. So the main thing to look for about not would make sure that it got 1 digit in the front and that 1 digit is between 1 and 9. Great job, Faith and Kennedy. I think you added some piece to that. Good job. Any questions about it?
Ma'am.
No, ma'am.
No, ma'am.
All right, I'm gonna give you about 30 seconds to a minute to have a look at the problem. Yeah, somebody asked for us to put it back on there. There you go. Let me know when you're ready.
I'm ready.
All right, I'm gonna give you about 30 seconds to a minute to have a look at that problem. It asked us to write this number in scientific notation. They then asked us to explain how we found our answer. Caleb or Cornelius, unmute and talk to us. How can we put this in scientific notation?
Take away all the zeros and put 3105 because scientific notation can't have a 0 in front of it.
All right, you said get rid of all them. What they gonna disappear?
Yes, ma'am.
Okay. Caleb,
Ma'am.
what you thinking? All right. So Cornelius got us started. He told us those zeros gonna somewhat disappear. We now got 3105. All right. Anybody else? You got something you want to add to us?
The exponent. 10 and the exponent.
Power.
All right. He said 10 and an exponent. So power of 10.
It's gonna be 7 because that's how many times.
Okay. 2, 3, 4, 5, 6, 7. Got us behind that 3. Good. So then don't forget that we need a decimal after that 3 to make sure it's just 1 in the front. Now let me ask you something. Would that 7 be positive or would that 7 be negative?
Negative.
It's a small number.
Good job. It's a small number. So then they told us to explain that. So we just solved it. How can we put that in words?
Because the whole number has 0 in the front of it.
All right. Bernice told us to get rid of those zeros. We added a decimal behind which one?
3.
Behind the 3. We added a negative to the exponent. Why?
Because the number was small.
Good job. Very small number to get 3.105 times 10 to the negative 7th power. So just remember, explanation don't have to be long and drawn out. You don't have to add anything specific to it, but just tell us exactly what you did to get that answer. Most importantly, it should be in your words or some words that you can easily relate to. Any questions about it?
No, ma'am.
No, ma'am.
Today, we used scientific notation from yesterday. We completed a class activity on scientific notation. Hopefully everyone went ahead and submitted that. And tonight you'll have 3 questions homework as you usually do. As always, take your time, show your work, do your best. Remember, I have one motto. Either I'm seeing the work or I'm seeing the explanation. Today is Tuesday, and I hope you all have a great Tuesday. See you later. What you say, Jamal?
It'd be more harder to show my work on it than just getting the answer.
Okay, I'll check into it and see. It may be about to pop up. It usually pops up after around this class.